Yes, class. Am I audible to all of you? Abdul, Khadija, Lina, Nuha. See, I just told you in the last class that I hope I'm audible. Yes or no?
Yes, ma'am.
All right. See, in the last class, I just told that one question on potential energy is left. That will complete off with the lesson. The portion of energy and work, because work we already did. Energy is left. Then today only we'll start with power. So see, a body is there that has mass m and it is taken to a certain height h. We have to show that total energy of a freely falling body is conserved. See, 2 points are there. This is point A, this is point B. So at both the points, we have to solve. So when we are taking at point A, the change in potential energy will be mgh, right? What about the kinetic energy? See, at the highest point, when we were doing motion in a straight line, I told you, remember motion under gravity, free fall. This is the case of free fall. No? So I told you that at the highest point, the value of velocity is 0. So change in kinetic energy for a point will also be 0. Why? Because velocity at the highest point is 0. Fine. So what is the total energy at a point? EA basically means total energy. So this means 0 plus mgh. This is equal to mgh. Now come to B point, the low. This is what we have solved for A point. Now come to B point. At this point, force into displacement will be 0, right? Why? Because height is 0. So force into displacement, this will be 0. All right. But this time kinetic energy will be existing. That is half mv square. Now, what is the value of this v square? This we have to calculate because we do not have any information regarding it. So see, v square minus u square is equal to 2as. Now this velocity is unknown. This velocity has to be calculated. This is the velocity vb I'm talking. Initially, it is at 0. Acceleration, see, displacement, if this is acceleration, will be acceleration due to gravity because it is a free fall case. And what to which height was the displacement occurred? H height, it was given. So VB square is equal to 2GH, right? And we also need VB square only. Here, let us substitute the value in VB. So what are we left with? See, change in kinetic energy of P. This is half m into V square. V square is 2GH. 2 will be cancelled. Kinetic energy is coming. mgh. Look at the total energy at B point. It is 0. This is equal to 0 plus mgh. So this is equal to mgh. See, EA. EA also came mgh. EB also came mgh. Right? So this shows what? Total energy is conserved. Hence, total energy is conserved. For which case? This is for free fall. Why this is for free fall? Because see, all the parameters here we have assumed is because of free fall. And why could we conclude this, that both are equal? Because the energy at A point came ultimately equal to energy at B point. This was our task to do. Fine, note it down. Then we'll start with power. See class, now the last portion. Actually, the last portion is collision, but before that, we have the concept of power. It's a very short portion that is given in your syllabus. So, because it's just an extension of what you have done in work done. When work is changed with respect to time, then you obtain power. Rate of change of work done. See, again, the term rate has come. Rate means, see, power is actually equal to whatever is the work done per unit time. That is the value of power. Means work done which is changing per unit time. Simple formula of power is work done per unit. So this means work done which is changing with respect to time. Like if in 2 seconds 3 joules have changed, so 3 by 2, that is 1.5 watt will be the power. It's a scalar quantity. And see, SI unit of work done is what? This is joules, time is seconds. So 1 joule per second, this can be written as 1 watt. So W is the symbol for it. All right. Now see, the way I told you in instantaneous speed, instantaneous velocity, you do not write, you do not use the formula as it is. Remember, velocity is also displacement upon time, right? But we do not use the formula as it is. It is displacement upon time. We see the condition. Depending upon the condition, we find out whether we have to find the relative velocity. We have to take the differences and calculate. When we are talking about power, here power is also equal to work done per unit time. So whether we have to differentiate, when do we have to take the change is exactly same as we have done previously. See, last time when we were doing this same concept in motion in a straight line, I told you that you have a specific duration given. If you will have a specific duration, like 2 seconds to 8 seconds, this is one duration, right? Initial timings are present, final timings are present. Or 2 p.m. to 4 p.m., 9 seconds to 10 seconds, like this, if the values are given. Then we calculate the average power. We take this average power is calculated by change in work done by change in time. How will you calculate this? See, change in work done is basically final work done minus initial work done. Change in time is final minus initial time. This is how you will calculate the time. Fine. Now see, if you are not given a duration, you are giving a particular time instant. Like time is calculate the power at 0.05 seconds. Calculate the power at 3.96 seconds. Like this, if you are having a power. So for that, in that cases, the instantaneous power will be equal to differentiation of it. Simply use this, you will get your answer. Here, take their change and calculate. Here, just simply differentiate. Fine. Differentiation is there. Note it down. Then one more thing we'll discuss. See, power is equal to dw over dt. This is the formula of power that we have seen. Here dw is work done, t is the time. Now formula of work done which we have already studied is force into displacement, F dot ds. ds here is displacement. Now if you put in the value of dw from here, so power is equal to F dot ds over dt. Now see, if this force is constant, if the value of this force is constant, then power will be Cf, then what is left? ds over dt will be left. Now what is ds over dt? Rate of change of displacement, velocity. So finally formula of power will become F dot v. V is the velocity, P is the power, and F is the force. This is power. See, this is one question. One more question we'll see. See, it says that a force of 10 Newton acts on a body and it starts moving with a velocity of 5 meters per second. Calculate the power. So power is equal to F dot V. Force is 10, velocity is 5. So power is 50 watt. This is a formula based question. Write it down and just one more question we'll see from this topic. See, this question says that a body of mass 100 kg is moving up in an inclined plane with the velocity of 10 meter per second, slope 1 in 5. See, when it says slope 1 in 5, this means sine theta is given. Sine theta is what? Sine theta is given as 1 in 5. 1 in 5 means 1 by 5. So whenever it is written, no, slope is 1 in 5, it means sine theta is 1 by 5. Now see, once you have, what is the value of sine theta? Sine theta is perpendicular upon hypotenuse. So this is the perpendicular, this becomes the hypotenuse. Now using, see, if you have P, if you have H, the third one can be easily calculated. This is 5, this is 1 unit. So you apply Pythagoras theorem, you get the value of cos theta, you get the value of tan theta. First apply Pythagoras theorem, see, h square is equal to p square plus b square. So from here you can get the value of b square. Once you have all the variables with you, p, h and b, all the variables with you, once you have it, then what you can do, you can calculate cos theta, tan theta, whatever is required. Now see one more thing, come to this figure as well. See, this block is there, downwards, mg is acting. I have told you this angle because this is 90, this is 90 minus theta. Again, this entire is 90, so this becomes theta. So this is mg cos theta because here angle is being made with the axis. And perpendicular to it is mg sine theta. Fine. And what is the velocity of this? Velocity is 10 meter per second. Now we have to calculate power is equal to F dot V. What is the force equal to? Look here, if velocity is applied in this direction, some force must be acting behind, right? So this force is actually balancing your mg sine theta. What is the force? Force is equal to, because see the normal reaction and mg cos theta, they are balancing each other. This velocity with which the force is being applied here in this direction, this is balancing mg sine theta. So F is equal to mg sine theta. Mass is 100, G is 10. Now see sine theta. Sine theta is given you as 1 over 5. So this becomes 2. This is 200 Newton. So this is just the force. Now for power, you have force into velocity. So force is 200 Newton, velocity is 10. So power becomes 2000 watt, or in short, you can write it as 2 kilowatt also. So these are the things which you have to remember in power. Every question is similar to this only. The rest of the questions, we'll start with collision now. But first write it down. Any doubts if you have, let me know. See, class, this is the last topic from your work energy in power, collision. Collision basically means when, see, first you have to understand when we are saying what are things that are occurring before collision, what are the things that are occurring after collision. See, this is one body M1 who is having mass M1 and the initial velocity is U1. Similarly, second body is present. M2 is the mass and U2 is the initial velocity. Now, this has started moving with a greater speed and has collided with this. See, this is the case where the collision is occurring. During collision, what happens? Both of them will be exhibiting forces on each other, so net force will be cancelled. F net will be 0 during collision. And then what will happen after collision? See, after collision again, M1 will move with a new different velocity now. See, suppose this was 5 meters per second. After collision, this has become 2 meters per second. Fine. Initially, this was more, this is less. So velocities will also be different. So this is the case which you have to remember. Now, collision is what? Collision is an isolated event in which the force, in which large force acts on the body for a short duration of time. So this is the definition of impulsive force. What have we studied for impulse? Force is acting for a very short duration of time, which results in change in their velocity. This is basically what is meant by collision. Now, physical contact is not necessary for collision, and collisions are also of different types. You have elastic collision, inelastic collision. Both of these we'll be studying in 1 dimension and 2 dimensions. 1 dimension, just understand. Then in 2 dimensions, you just have to perform resolution of vectors that you can do. Now, differences between elastic and inelastic collision. Firstly, elastic collision is valid for all the conservative forces which are acting. Conservative forces in the last class we have discussed, the forces that that depend upon the initial and final path, they do not depend upon the entire path travel. In inelastic, non-conservative forces, that is the dissipative forces like heat, friction, viscous force, these types of forces act in inelastic. Now, in elastic collision, there is no loss of energy, but in inelastic, there is loss of energy in the form of heat and sound because dissipative forces are present, so energy will be lost. Then potential energy. See, when we're talking about things that remain conserved, momentum, total energy, they are conserved in both elastic also, inelastic also. Kinetic energy is the one which is just conserved in elastic here. It's not conserved in inelastic. This is a point of difference which you have to remember. Class, when you're writing this, not write it in tabular form so that you will know the differences where all the differences between these are present. Elastic, inelastic, just make it in the form of table. Note it down. Yes, class. Have you completed till here? Written the differences or still writing? Yes. Still writing, Khadija, Leena, Nuha, Abdul. Am I audible to you or not?
Yes, ma'am.
So why you people are not responding? You people have written or do you need more time to write?
We've done.
Done, no? All right. Let's move further then. See, these were the basic differences point, elastic and inelastic. Now, this table can come to you in the exam. This is there. You have the points written. From here, no definition is asked for collision usually, but coefficient of restitution is asked. See what is meant by coefficient of restitution. First, understand this. Coefficient of restitution basically means, see, this we have done how the bodies are moving. They have their own velocities. During collision, the velocities get changed. Now see, if both the bodies are moving like this is a little behind than this body. This M1 will have to go with a greater velocity. Do you understand? See, if it keeps on moving like this with the same velocity, they'll never be able to collide. It will always be behind M2. So M1 has to move with a greater velocity in order to overcome M1, M2. That's why only collision will occur. Otherwise, what will happen? M1 will be behind M2 throughout because the velocity, if it is less. So U1 has to be greater than U2. All right. Now, if U1 is greater, how do we calculate relative velocities between two bodies? VAB is equal to VA minus VB. Simply you subtract the objects whenever you have to calculate their velocities. So relative velocity of approach means the relative velocity between these two. That is what is meant by it. Relative velocity between M1 and M2. So what will be the relative velocity? U2 minus U1 or U1 minus U2? U1 is greater, so it should be U1 minus U2. This is the relative velocity of approach. Now collision has occurred. So now what will happen? After exchange of velocity, this will now be back to its original velocity. It will be having certain new velocity. See, these were the original velocities. They have collided. Here, look, this is the process during which collision is occurring. Once they have collided, then they are moving with different velocities. So now V2 will be greater. So relative velocity of separation is V2 minus V1. See here, do not make this error U2 minus U1, U1 minus U2 and V2 minus V1. So this is relative velocity of approach means before collision when they are approaching to each other, their relative velocities. And here also after separation. Relative velocity of separation means they have separated. Now look, what is meant by coefficient of restitution? Coefficient of restitution is basically ratio of relative velocity of separation. What is relative velocity of separation? V2 minus V1 to relative velocity of approach, that is U1 minus U2. This is the formula for coefficient of restitution. Now see, when you substitute in all these values, no, this is represent coefficient of restitution. This is denoted by this symbol E. So when you put in the actual values and through experiment also, it was concluded that exactly value of coefficient of restitution for elastic bodies will be 1. For inelastic, it will be 0, less than 1. And for perfectly inelastic, it will be 0. Now see here, this is elastic is fine. Inelastic is fine. What is meant by perfectly? Then inelastic is there. Perfectly inelastic means this stage is not arising. Bodies, when they have collided, they are stick to each other and they are moving also with their stickness together. Like this only they will move with a common velocity. They'll not be separate, M1 here, M2 here. So anyways, inelastic, we can see this in your class also. So that is what is meant by it. So why is it 0? See, there is no relative velocity of separation. This relative velocity of separation becomes 0 because the body's velocities are not existing. They are the same velocity. So that's why we have the coefficient of restitution as 0. First, tell me, is this concept clear? What is meant by coefficient of restitution? Or should I ask you all people questions? Clear or not? Nuha, you have understood this concept?
Yes, ma'am.
What about you, Abdul? Leena, Khadija, understood or not? Yes, ma'am. Write it down. See, these values are specific for these elastic and inelastic, but for different conditions, you will have to calculate it by yourself.